Good morning, everyone. I'm Saif. I'm doing my PhD at Bioresource Engineering. My presentation topic is integrations of remote sensing and proximal soil sensing in precision agriculture. Now I am giving you a brief introductions of this presentation. So various technologies now assist for making sustainable environmental strategies. So proximal soil sensing and remote sensing is one of them. The proximal soil sensing that is collected information very close to Earth's surface and plants. And remote sensing that is also collected from above 2 meter of the ground surface. Both of this technology is making a robust methods for proximal soil sensing system and in precision agriculture. So now I am talking about the various platform of these two technologies. The remote sensing have three platforms. The satellites is above 800 kilometer, the aerial photography system, and the UAV system. Mostly the aerial photography and UAV systems are very useful for precision agriculture. But the proximal soil sensing system, they have on-the-go system, on the spot, stationary system, and the different depth or soil profiling system. So this technology is also helpful for precision agriculture. So how can we useful for these two technologies? So both of these technology are near real time or real time data provided for this application. So wider coverage also helpful for identifying big farms and monitoring them. Also, the high spatial resolution also helpful for small variability and homogeneity in the field area. And now the multispectral data also useful for detecting the variability in the farm and the plant variability of the farms. So now the integrations. So when the sensor is collected data, then the sensor sending those information to ground receiving stations, and then the ground receiving station sending it to the users and the researcher, and then the researcher process it, making thematic maps, and then this thematic map also useful for variable rate technology and various applications for the precision farming. So now I am talking about the how it works. So when we collected the satellite image on the off season, means there is no crop in this field, then we process the data. We also collected soil samples and lab chemical analysis of the soils. Then we put it together into GIS system. Then we supplied this thematic map to variable rate technologies for tillaging, seedling, for fertilization, and also for plant protections. And now we take the another photo when the plant is growth stage. So then we process the data how the plant is growing, and then it also helpful for plant harvesting system. So then we collected various data sets from these two technology. Like elevation, we collected from the RTK system. Also PSS sensors collected various data sets. And the soil sampling data we collected from fields, and also yield data. So these layers are integrated together and produce a nice thematic maps for identifying a small variability of the farms. Now the applications. So the yield maps, the sensing data, topographic informations, farmers knowledge, and the satellite image, the lab data, those are also useful for best management practices, and also very useful for variable rate technology. So now in conclusions, so both of these technology are very important for identifying soil properties informations, and also for soil specific fertilizer and crop management. So the integrations of these two technology and advanced soil mapping techniques also promising benefit for precision agriculture. And these two technologies and suitable measured variables, also the statistical models, also be useful for identifying the precision farming. Thank you for Professor Dimo, Christopher, and the audience. Thank you so much.